In computers, we often refer to the transmission of data in terms of parallel and serial, but what exactly do these words mean? Well, in order to understand them, we first need to understand how computers interpret data. Computers use binary digits, or bits as they're more commonly referred to as, in order to understand what the data is. A binary digit is either a 1 or a 0, on or off. Serial transmission is when these bits of data are sent one at a time, one after the other. Think of when you enter a stadium. Only one person at a time is allowed through the turnstiles. Parallel, on the other hand, is when the data is sent multiple bits at a time, like when you leave a stadium. All the people just flood out the doors. Just more organised with parallel. So why do we use both? Well, they each have their advantages and disadvantages depending on what data needs to be sent and received, and how it needs to be sent and received. For example, parallel, although usually much faster than serial, would be no good for something like Wi-Fi, where the signals are being broadcast all over the place in the air because each bit needs to arrive at the same time. But if the signal is being broadcast all over the air, with each bit encountering a little bit more resistance than the other, they'll all arrive out of sync. So Wi-Fi is serial. Other examples of serial connections include USB, which for those unaware stands for Universal Serial Bus. What about parallel then? Well, parallel connections, as we've said, allow for multiple bits at a time to be sent down multiple lines. Think of a processor inside your laptop or computer. The chances are, unless you're living in the Stone Ages, it's either 32-bit or 64-bit. This means that the data can be sent through your processor 32 or 64 bits at a time, respectively. So in some applications, parallel is faster than serial, but in other applications, parallel just really wouldn't work out.